Hello everyone, I'm Sudhir Hasbe. I'm the Director of Product Management for Smart Analytics Platform at Google Cloud. I've been with Google for 2.5 years. Prior to that, I was VP of Engineering and Product at Zulily, and before that, Xbox Azure. Um, the size of data across organizations is growing. By 2025, there will be 175 zettabytes of data according to IDC in the world. And unless you have a very strong analytics platform, it's very difficult to go ahead and be great as an organization on AI and machine learning. Um, at Google, we have built a very strong analytics platform over past many years. We have more than 9 products with more than billion users. We collect massive amounts of data. We provide great features and capabilities based on that data. We get a lot of insights from that data. And in Google Cloud, we are actually trying to take that infrastructure and make it available for our enterprise customers. As we have been working with a lot of customers worldwide, we have seen few of these trends, technology trends that are emerging in last few years. First of all, data silos within organizations are breaking. As more and more organizations move to cloud, they want to go ahead and do analysis across all of their data, not less or minimum or some set of their data. So for example, data lakes and data warehouses, these were the concepts that were there in past. They are breaking, the barriers between them are breaking. Organizations are looking to analyze data across all of their data between data lakes and data warehouses. Second, a lot of systems in historical terms were built for batch processing. It was okay to go ahead and process some data, get a report tomorrow about what happened today. That's not happening anymore. A lot of changes are coming in the world where we want to get real-time access to data, make real-time decisions for our customers as well as our organizations. And then finally, the boundaries between analytics and AI are merging. We have seen different studies which show 80% of the time data scientists are spending in data preparation rather than AI and machine learning. And I think making it easy to go ahead and do this data preparation for data scientists, but making it easy for analysts to do machine learning and AI is also growing as a trend, and then that's what is the need from our customers. So if you look at those trends and our background as Google and Google Cloud, our core vision is to provide an enterprise cloud data platform for our customers. That's one built on a proven and dependable platform, which is like Google. We run global scale services. We are building on top of that platform. Second, we want to be completely open. We want to support open APIs, open source software. We run a lot of that on the platform and make that available. We want to be flexible for our customers, want to provide what our customers need. And then finally, we want to embed intelligence across the portfolio. We want to make our products better with the AI and machine learning capability, but also make AI and machine learning more accessible to our organizations. And we'll talk more about that in next few minutes. One of the core philosophies that we have is this serverless. We believe in serverless data analytics. What does that mean? What it means is we want organizations to bring their data in and start analyzing. Don't worry about infrastructure. Don't worry about monitoring, scaling, resource management. The whole focus should be bring your data in and start analyzing the data on the platform. With that, if you really look at the solution, like we have various services in Google Cloud Platform that enable you to collect data at scale. You can collect it in batch or stream fashion. You can go ahead and then process data. Dataflow is a great service which allows you to do batch and stream processing on the platform. You can also use Dataproc, which is actually managed Hadoop and Spark environment on Google Cloud. And then you can store and analyze their data with BigQuery. And then once you have the data in BigQuery at scale, some of our largest customers have like massive hundreds of petabytes of data. You can then leverage Tableau service on top of it to go ahead and visualize it, analyze that data, and create interesting insights from that data. Along with Tableau, of course, we support various other partners, but Tableau is one of our top partners that many of our customers use. With that, if you actually look at BigQuery, BigQuery is a global scale, cloud scale data warehousing solution. We have customers that span from few terabytes to hundreds of petabytes in scale. It's completely serverless product, so you just bring in your data and start analyzing. It has inbuilt capability to ingest tens of millions of events in real time directly into the data warehouse without impacting the query performance. It has embedded machine learning. I will talk a bit more about that. And then it enables you to derive insights for everyone in the organization. We can basically scale to go ahead and give insights to anybody within the organization, and its insights are not limited to very few folks. So let's talk about a few numbers. BigQuery, some of our largest customers are in hundreds of petabytes. The largest one has more than 350 petabytes. The largest query that was ever run on BigQuery was 100 trillion rows plus. And then we have seen concurrency of more than 10,000 queries that organizations have run on BigQuery. With that, one of the things we have focused on is also how to make it really easy to get data into BigQuery or access other data outside of BigQuery from the same environment. So you have, like, with no code, few clicks, you can actually get data from 100 plus applications, including Salesforce and various other SaaS applications that you have in your environment, or Google Ads and Google Analytics and all. So you can get that into BigQuery just with few clicks, or you can leverage BigQuery to analyze your data in your data lake, in data or in various databases and all. So that capability is available so that you can use that. One of the other things about BigQuery is it's basically, we have been in market for more than 10 years. It was our 10th anniversary in June. The key thing is we pioneered the concept of paper query. It's great for organizations who are getting started, but a lot of organizations want flat subscription-like pricing, so it's very predictable. And so we have introduced that, so you can go ahead and use the flat rate pricing. Or recently, we have also introduced flexible pricing or flex lots, where for burst scenarios, you can go ahead and use that pricing model. The beauty of our pricing model and workload management is you can mix and match this for various of your workloads within an organization. So you don't have to stick to just one single pricing model. You can just select by workload what you want to go ahead and do. One of the other key capabilities BigQuery provides is embedded machine learning. You can write 2 lines of SQL code to go ahead and create machine learning models. This is really popular. Organizations like Zulily and various other organizations are leveraging this ability, where an analyst now can create a machine learning model and then train it, do predictions with just few lines of SQL code. Now, one of the things that we have added is, over a period of time, various different types of models. So everything from regression models, k-means clustering. So if you want to go ahead and do customer segmentation, you can just use k-means clustering. You want to do product recommendations, we have matrix factorization. We just launched time series forecasting that can be used. And one of the other key things is you can actually take the model built in BigQuery, export it into TensorFlow, and actually host it in your hosting environment. So you can have a real-time website being powered by the same model through TensorFlow exports that we have made available. With that, one of the other key themes we have in Google Cloud is around real-time analytics, and BigQuery is a great system for doing that. Now we have just rebuilt whole of our storage engine to be streaming first, and we are now able to support tens of millions of events per second with exactly one semantic. We introduce materialized views so that we can pre-aggregate data for you, so you don't have to go ahead and do that in a scheduled fashion. As the data comes in, as the data changes, we automatically go ahead and pre-aggregate with materialized views. And one of the other key capabilities that we have announced is a BI engine. BI engine basically is our ability to go ahead and have a in-memory caching system which can actually horizontally scale. It gives you sub-second queries. It has a very simplified architecture, and it enables smart tunings. So let's think about what that means. Sub-second queries, basically, it's a columnar-oriented in-memory execution engine. It can horizontally scale, and you can take any data set, and we should be able to go ahead and give you sub-second response times. In many cases, smaller data sets, you'll be in like tens to hundreds of milliseconds in response time. One of the other things is it will natively work with most of the BI tools because we are actually going ahead and moving it behind from an architecture perspective behind our BigQuery API. So any query that comes into BigQuery actually can leverage this caching layer. We have great integrations that we have already done with most of the BI products. We are going to see today how it works with Tableau. I've seen the demo myself. It's one of the like it's really snappy and it's really easy to go ahead and use. And then again, it works on OLAP cubes. We will support BI workloads with star schemas and stuff like that. So that will be available. From smart tuning perspective, it automatically can tune your query. So when the queries come in, we will automatically, instead of going to the raw data, we'll use the cache whenever it's available. We will keep the cache updated whenever the underlying data changes for you, so you don't have to worry about anything. Whenever you want to increase or decrease capacity, you can go ahead and do that from the UI itself. And then you have access to all the metrics. We are all about data. We want to make data available to everybody. So you have visibility into whatever the aggregate refresh times or cache hit ratios or latencies. Everything is available to you in form of data within BigQuery. Now with that, let me invite Madeline Corneli, product manager at Tableau Technology Partners team, to go ahead and show us a demo of how Tableau and BI engine integration works. She works closely with Tableau's strategic cloud partners like Google Cloud to provide great experience for our joint customers. Madeline has worked with Tableau for 5 years, and she is always excited to see how technologies can help people do even more with data.
Thank you, Sudhir. Hello, everyone. My name is Madeline Corneli. I am a product manager for Tableau's technology partner team. I work closely with our strategic partners to improve integrations between their services and the Tableau platform. Today, I am very excited to demo Tableau and Google BigQuery's new BI engine functionality. We're going to start off in Tableau Desktop, and the first thing I'm going to do is I'm going to connect to my Google BigQuery instance. Then I can choose what data I want to analyze today. To leverage BI Engine, all I need to do is ensure I connect to the billing project where BI Engine is enabled. Then I can select the project and dataset where my data lives. I'll then pull out the table or tables that I want to analyze today. Hopping into our first sheet, I can pull out the number of records field to quickly see that we're working with a data set of over 87 million rows. That's a pretty hefty data set to work with. Now this data contains lots of customer reviews of various health and beauty products sold by a company called YLM. I can use Tableau to quickly aggregate the overall reviews for all of these products. Looking at the average review, I can see what of our products have scored very high and which ones haven't scored as high. Tableau also makes it easy to quickly switch between various visualization types. Let's call this product reviews. Now each of these products lives in various different categories. Tableau makes it very easy for me to group these various categories together into something we call a hierarchy. I'm going to create a new hierarchy called product. And by doing so, it makes it easy for me to drill up and down between various levels of granularity in my data. Now for this view, I'd like to get a sense of the overall quantity of sales I have for each one of my categories. I'd also like to add the context of the average rating as well. Now, every time I use aggregate rating here, I'm typically going to want to look at the average overall. So I'm going to set the default property to use average. I also want to change the color scheme as well. I want to make sure that I don't miss any of these products that may have lower reviews as I go through my analysis. Now I can see that there are certain product categories where I have a high quantity of sales, but the aggregate rating isn't very high, and that might be something I want to investigate. Let's call this product reviews and quantity. I'd also like to look at this data geographically. This dataset already includes state information, so I can simply drag state out onto the view, and Tableau will plot that for me. Now I can also add quantity as well, so we can see which states have higher quantities sold. I'm going to add aggregate rating to the view again, and I can see that generally the states where I have higher numbers of sales, I also typically have better product ratings. However, there are some problem areas that I may want to investigate. I can easily drill down to a lower level of detail to figure out if there are specific cities where I have high quantity but low ratings. Let's bump up the size a little bit so it's easier to see. We'll call this product ratings and quantity by city. Finally, I want to pull together all of these visualizations onto something we call a Tableau dashboard. Using a dashboard makes it easy to compare multiple visualizations at the same time. It also gives me the ability to add interactivity between these various worksheets. Doing so effectively creates an interactive application that lets me visually explore my data. I can look at some of our problem subcategories and select a particular region to explore in more detail. And finally, I can pinpoint exact products that have low reviews. And so with that, in just a few minutes, we've built an interactive dashboard on top of over 87 million rows of data, thanks to BI Engine. Now I can publish this to Tableau Server or Tableau Online and share it with other people throughout my organization.